Hello. All right. So, purpose of this video is just to get you exposed to a bunch of different exponent rules. So, anyway, let's begin. All right. So let's say we want to simplify the following expression. So x raised to the 12th power times x cubed. Okay. So if you guys saw in the video, so there's a rule that says if the base if you have the same bases, just like this, then what you can do, if the same basis would be x in this case, you can add the exponents together. So this would be x raised to the m plus n. So in other words, this is the same thing as x raised to the 12 plus 3. So that's just x raised to the 15th power. And that is how that would be simplified. Okay? Number 2. Okay, x raised to the 7th divided by x raised to the 4th. Okay, so now this one will use the rule x raised to the m divided by x raised to the n. And if you see division here, if the bases here, the x's are the same, what you would do is you would subtract the exponents. Subtract the exponents. Okay. So what this means here is this is just x raised to the 7 minus 4, which is x cubed. Okay. Third one. Okay. X to the 4th power raised to the 5th power. Okay. So this one uses the rule. So you have x raised to, this is going to be x raised to the m raised to the n. And that's the same thing as x raised to the m times n. Okay. So what we have here is this, you just multiplied exponents. So in other words, you're doing x raised to the 4th times 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 x raised to the 4th. So 4 times 5 is 20. Okay. So that's how you would do that one. Okay, I'm going to clear the screen because this is getting a little messy. All right, so fourth example. Here we go. Fourth example. X squared y cubed raised to the 4th power. Okay, so one way that you could do this is you could write it all out. You could write x squared y cubed times x squared y cubed times x squared y cubed times x squared y cubed. You do all of that. So x squared times x squared times x squared times x squared is x raised to the 8th. Y cubed times y cubed times y cubed times y cubed would be y raised to the 12th. Or in other words, in this one, you can use that rule and you can just multiply the exponents. So 2 times 4 and 3 times 4. Okay. Fifth one. Okay. So we have x raised to the 6th divided by y raised to the 7th. And this whole quantity is squared. Okay. So a couple ways that you could do it. You could write it out. X raised to the 6th divided by y raised to the 7th times x raised to the 6th divided by y raised to the 7th. Now, if you guys remember how fractions work, you multiply across when you're multiplying. So x raised to the 6th times x raised to the 6th is going to be x raised to the 12th. And then y raised to the 7th times y raised to the 7th is going to be y raised to the 14th. That is basically how you would do that one. Yep. Okay. Let's see. Number 6. Okay. So number 6, x raised to the 0 power. Again, what I mentioned, anything raised to the 0 power. You see that right there. Anything raised to the 0 power is 1. Anything raised to the 0 power is 1. That one is easy. Now, x raised to the -3. Okay, so there's a rule. There's a rule for negative exponents that says x raised to negative n is the same thing as 1 over x raised to n. Okay? In this case, n is 3. So what we do to simplify this is just 1 over x cubed. That's it. Okay. Number 8. So let's see. X raised to the 4th divided by x raised to the 7th. Okay. So again, what we can do is we can go ahead and use some rules. So we have x raised to the m divided by x raised to the n. And it's the same thing as x raised to the m minus n, right? So in other words, we just take 4 minus 7, right? So x raised to the 4 minus 7, and then 4 minus 7 is going to be negative 3. If I put a plus and a minus here, 4 plus a negative 7, you're going to get x raised to the negative 3. Now we can simplify this further, and this becomes this here. So what we can do to simplify this even further is this is the same thing as 1 over x cubed. So believe it or not, these two expressions are the same thing. Oh my goodness. All right, so let's see. Number 9. Okay, so here we go. 6 cubed times 6 to the 4th power. So as you see here, the bases are the same. Since the bases are the same, you just add the exponents. So 6 raised to the 3 plus 4. So that would be 6 raised to the 7th. I don't know what it is at the top of my head, but that you could go ahead and do 6 times 6 times 6 times 6 times 6 times 6 times 6 if you want. Okay, next one. All right, 5 raised to the 7th power divided by 5 raised to the 3rd power. Okay, so this is just a subtraction rule. The bases are the same. So when you have division, you subtract the exponents. So this is 5 raised to the 7 minus 3. So this is 5 raised to the 4th power. So in other words, it's 5 times 5 times 5 times 5. Right, 11. So 2 cubed raised to the 4th power. Okay, so again, think of it this way. It's the same thing as 2 cubed times 2 cubed times 2 cubed times 2 cubed. Or in other words, 8 times 8 times 8 times 8. And then this would simplify. So if you just multiply the exponents together, this is 2 raised to the 12th power. So go ahead and do that. You can also try 8 times 8 times 8 times 8. And I believe it should be the same thing as this. Okay. Next one. Okay, so number 12. All right. 33 raised to the 0 power. So again, what I mentioned was anything raised to the 0 power is 1. Anything raised to the 0 power is 1. Okay, number 13. All right, 9 raised to the negative 2. All right, so we're using that same rule from earlier. We're using that same rule. So if you have a negative exponent, the pattern is it's always going to be 1 over, and then you put the base on the bottom, followed by the positive part of the exponent. So 1 over 9 squared. So 9 times 9 is 81. Boom. Okay. Number 14. All right. So this one is a little bit, there's a little bit of things in here. 2 raised to the 5th times 2 raised to the 4th divided by 2 raised to the negative 3. Okay. This one will take a couple rules. So what I see here is if I look at this here, right? So I can see that I can use if I'm multiplication, I add exponents. So 5 plus 4, so this is 2 raised to the 9 divided by 2 raised to the negative 3. Okay. Next, what I see here is I'm going to use I see division, so I'm going to subtract the exponents. So this is 2 raised to the 9 minus a negative 3. Now, if you guys get something like this, the two negatives, they should cancel out. So you get 2 raised to the 9 plus 3. So that's 2 raised to the 12th power, right? let's see. I'm going to clear the screen. Number 15. Okay, so 3x raised to the 5th times 4x squared. Okay, so what I see for this one is there's a 3 here and there's a 4 here. So 3 times 4 is 12. X to the 5th times x squared. So again, the bases are the same, so you add the exponents. So 5 plus 2 is 7. Boom. Okay. Number 16. Okay, so what I see here is 9x raised to the 0 power. Okay, anything raised to the 0 power again. If you guys have been paying attention earlier, it's 1. Number 17. Okay, 2x y raised to the 4th cubed. Okay, so this one, you could go ahead and write it out. You could go ahead out and write 2xy to the 4th times 2xy to the 4th times 2xy to the 4th. And what you'll see is it's the same thing as distributing that exponent in. So it's 2 cubed. So 2 times 2 times 2. It's going to be 8. X times x times x is x cubed. So you're doing y raised to the 4th times y raised to the 4th times y raised to the 4th. And this is y raised to the 12. Boom. Okay. All right. Number 18. Okay, so x squared times y raised to the 5th divided by x y raised to the 4th. Okay, so what I see here is what I'm going to recommend is you can split this up. If you split this up, I'm going to make nice little colors here. So this is x squared divided by x. And I can also split this up here. This is y raised to the 5th divided by y raised to the 4th. Okay, so what I see here is you can use the subtraction rule, and then we can take this separately. So for this green part, if you subtraction rule, you have division, 2 minus 1. So x raised to the 2 minus 1 times, and then y raised to the 5 minus 4. So in other words, you're left with x times y. Okay. Another way that you could do this is you could also go ahead and do it this way. You could just write x times x, and then you could write times y times y times y times y times y divided by x times y times y times y times y. And then you'll see that x cancels out here and a bunch of y's will cancel out. And then you're just left with an x and a y, which is exactly what you have there. Ho ho, ho 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 ho. Okay, so number 19. Okay, so 2z squared times w over y raised to the 4th. Okay, so for this one, what I see is, yeah, you could go ahead and write it all out if you want. 2z squared times w over y times 2z squared w over y times 2z squared w over y times 2z squared w over y. Yeah? So if you had to go ahead and write that out, basically the top part, 2 times 2 times 2 times 2 is 16. Z squared times z squared times z squared times z squared is z raised to the 8th. W times w times w times w is w raised to the 4th. And y times y times y times y is y raised to the 4th. Now, another way you could do this, just makes you distribute the exponent into the numerator and denominator as such. So it's 2 raised to the 4th power 16. Z squared times raised to the 4th power is z to the 8th because 2 times 4 is 8. And then here you have 1 times 4 is 4. And then this here, 1 times 4. Number 20. All right, so 52y raised to the 6 divided by 13y raised to the negative 8. Okay, so Couple ways that you could do this. You could do this, 52 divided by 13, and then treat that one separately. So 52 divided by 13 times y raised to the 6 times y raised to negative 8. Or if you guys just see a pattern, you could actually just skip all of this. So 52 divided by 13 is 4. Y raised to the 6 times over y raised to negative 8. So remember, that's a subtraction rule. So y raised to the 6 minus a negative 8. So you're going to get y raised to the 14. So this is 4y raised to the 14. Okay. 21. Okay. W raised to the 4th raised to the negative 8. Okay. So what you want to do for this one is you're going to, if you remember the rules already, you can multiply that in. So this is w raised to the negative 32. Now just remember, if you have negative exponents, you can also write it with the positive exponent in the denominator. So this is 1 over w raised to 32. Okay. 2 more problems. Here we go. Number 22. 4x raised to the 4th. Y raised to the negative 4th. Cubed. All right. So same idea. If you guys starting to see a pattern, this is 4 cubed. Then x raised to the 4 times 3. This is 12. Y raised to negative 4 times 3. So y raised to negative 12. So 4 cubed is 4 times 4 times 4. So that's 64. X raised to the 12. Y raised to negative 12. What I see here is I can actually rewrite this as a fraction. So 64 times x raised to the 12 multiplied by 1 over y raised to the 12. So you guys see this here is the same as this. Now, let's say we were to just to help some of you out, that you can simplify this further. I can put this over 1. I can put this over 1 and then multiply everything together. So I have 64x raised to the 12 divided by y raised to the 12. Ooh, yeah. All right. Last example. Number 23. All right. 8x raised to the 5th. Y raised to the 4th divided by x raised to the negative 3 times y. Okay. So this one, what you would do is, what I would recommend is you can split all of these up. So this is 8 times x raised to the 5th divided by x raised to the negative 3 times y raised to the 4th divided by y. To help you out, I'll just put a 1 here just so you can kind of see that. And you can treat all of these separately. So this is 8 times. So this part, the bases are the same. 5 minus a negative 3 is going to be positive 8. Y raised to the 4th divided by y to the 1st power. It's the same thing as 4 minus 1, so y cubed. Your final result is 8x raised to the 8th, y cubed. Boom! And that is your 23 problems on exponents. Yay. Now I gotta figure out how to end this. Oh, there we go. There we go. There we